So we've got our individual images in, but that's not that interesting looking at just these grayscale images. We want to see things in color. It's more interesting. And so to do that, we want to build a layer stack. We want to not have 7 or 6 individual files here in isolation, but we want those guys to be combined. And we can do that using this toolbox guide called build layer stack. And so we open this guy up, and just like, all right, it's sort of thinking, and if you want to learn more about it, you can always click on, this question mark guy, and it'll give you information about, okay, how do you build layer stacks and what's happening and such. So I highly encourage you guys to read that information so you know what's going on. But basically, what we're going to want to do is we're going to want to add different bands of interest into this tool. And so we want 1 first, and then 2, and we want to do this in order, 3, 4, 5. We don't have a 6, but then we just want to go to 7. Make sure that guy happened. Okay, so those are there. We want to choose the defaults. It's all fine. We want to give this guy a new name. Actually, I didn't want to collect a coordinate system. I want to talk about the output file. And again, in yours, you're gonna name this in a place. And if I go back to the lab, we are interested in creating a layer stack. I'm looking through here, and I want to know output file name of Landsat band stack. Okay, in your working directory, Landsat band stack. That's what we're going to call this. Oh, I've already done it, but I'm going to call it band stack 2 just to go through this process. And I'm going to say save, and then I'm going to say okay. And this guy is going to work away. It's going to build this layer stack by basically adding all these different files together into a single combined image. And there it is. And right away we see some interesting things, that no longer are we living in this grayscale world. We are now living in a colorful, vibrant world. And automatically it should have populated with red, green, blue channels of your monitor. Your monitor, what we're looking at light is combinations of red, green, and blue light. And band 3 has been assigned to the red channel, band 2 to the green, and band 1 to the blue. And that's great because this corresponds to band 3. If you look this up, is red light, and band 2 is from the green portion of the electromagnetic spectrum, and band 1 is from the blue portion of the electromagnetic spectrum. So this is basically a true color image. We can see, green grass. We can see all kinds of different things here. If we were potentially interested in changing how that looked to create a false color image, there's this handy guide down here that we can play around with, and we can actually, change the red monitor channel to 1, 2, 3, 4, 5, for example. Oh, and that really changes what we're seeing here, because now red color is no longer associated with the red portion of the electromagnetic spectrum. It's associated with the longer wavelength portion of the electromagnetic spectrum. We can do any kinds of different combination changes we want. We could make blue out there, or this guy, right? So they're very, and they can highlight different patterns of interest. There's also other ways of adding different band combinations and doing different games. So these sort of false color images, they look pretty wild, but they can tell us some interesting things about the data, and that is based on the different the different amounts of radiation that's being bounced off of the surfaces from different parts of the electromagnetic spectrum. Another way to visualize that is to use this spectral profile tool, which you can get at from here, or you can go under display profiles, spectral profile. And what this is showing you for band 1 in the layer stack, right? In the layer stack, it's got 6 bands, right? And the 6 bands correspond to band 1, 2, 3, 4, 5, and 7, you know, from the satellite. And that's what we're seeing here, right? And so this 5th one, right, which we've now got green assigned to the 5th one, this is higher. It's got a higher value than any of the rest of them. That's why this is appearing green in the background. If we, you know, change that and we wanted blue to be in the 5th position, oh, now it's, you know, dominantly blue, but actually purple, because there's some interesting things going on when you combine these guys. And similarly, we could make them all band 1. That wouldn't be very interesting, but we could sort of do that. And now, oh, it looks kind of grayscale and drab and boring. So every single guy, red, green, and blue on our monitor is going to be the same value over here. So that it'll be more like a grayscale guy. And if I did something like this, oh, it's very, very, very red, right? So you can play around with all these different variables. And as I go, let's go to water. So what do we think is going to happen if I click on water? This is, I'm in some kind of a field right now, and you can see our different values. And you can click on here to see the actual, you know, Y values of these particular guys. If I go to water, right, this is 60, and then these guys are very, very low out here. So in this water body, this is, you know, this is like 13, right? Where if I go out here, for this band 4, it's 65. This is a dynamic Y-axis. You can change that, but by default it's dynamic. So it'll jump around to fit the data. So just kind of pay attention to that. And as you click in different places, you'll see different patterns. These are not reflectance values. These are raw digital numbers. And so these have not been atmospherically corrected to get to reflectance values, which is often what we want. This is a more a raw product that hasn't gone through atmospheric correction. And so just keep that in mind when you're looking around at these different data values here. They do correspond to roughly the amount of light that's being reflected, but it hasn't been converted all the way to reflectance. They're in raw digital numbers. Okay, great.